So of course we've done one of these before, the Midland 3001, and it belongs to the same customer, the same bulk trade customer as that TTI TCB 900 that we did yesterday, and this set is actually from his own personal little collection of CB radios, and it's immaculate. So let's try and keep it that way. Why is that screw not wanting to come out? We're going to have to get the bigger screwdriver to that. So we've got the factory original mic with it. How weird. I can't remember whether those let you get the chassis out or not. I mean, how many times do we actually see these side brackets? So he just wants a general service on it. I don't think there's any specific snag with it. And I know at the time these weren't the best of radios with the Maxon chassis that can certainly suffer from descents in those areas where there's a silver rod base station area like every other house. But they've been very reliable, and these days with far less users isn't a problem at all. Right, let's see what transmit it's doing. So I'll switch picture and picture on. And all the time I've been spouting, you've had a picture of an out of focus meter. We're talking about the Midland 3001 because I'd pressed the wrong button. Okay, so back to what I was saying. Okay, so we've got no transmit. So the first thing we can do there is we'll plug our extension speaker into the public address socket. Right, let's try again. So we're in PA. That switch seems loose. Testing 1 2, testing 1 2. 1 2 1 2, testing 1 2. And while we've got quite low volume on PA, 1 2. Now we've got transmit, so we had a dirty PA switch. And we're doing a lousy, oh dear, we are doing a lousy 1.7 watts. Well, I think I've still got the Comtron one on the clipboard. And the answer is no, we haven't. We better pause the video and I'll find the information. Okay, well, we're going to have to do another sheet. I don't know where the proper one's gone. Perhaps it's got filed away. So what I'm doing, I've got the layout from the Midland 3001 instruction book, which that was included in, and I've got the instructions from the Maxcom 4E, so it's more or less the same. So the first thing we need to do is check we've got coils 107, 9 and 8 for maximum. So that's that and that. Now, no point doing the VCO because the radio's in lock on 40 and 1 and it's clearly never been touched, so there's no reason for me to do that. And those of you who work on these sets, often the test point isn't even fitted, so it becomes a bit of a pain to find where to prod. So we'll go back to where we started, apart from when I just showed you an out of focus fuzzy meter. I'm going to transmit. So more or less on frequency. I'll show you that right now. In fact, we may as well trim that right now. We'll do that first. 27.79121 should be 27.79125. There we go. Spot on. That's one job done. So we'll go back to the meter, and it says 107, 9 and 8. So 107, 109, 108. Looks like it's been untuned. Well, that's an improvement, is it not? 2.5 watts now. I've got a sneaking suspicion that one's broken. Let's see whether it's just got wax in it. Got wax in it. Good. So 2.6 watts. Okay, so let's go to the scale now. So we're at 3 watts. That's 3.3 because the radio is now warm. So I'm going to go backwards and forwards on these till no improvement can be achieved. Just going to check we've got 13.8 volts because normally these easily do 4. And I'm on my power supply with analog meters. Yep, that's near enough, 13.8. So I'll pause the video, we'll go backwards and forwards on those off camera. Okay, so we more or less got 4 watts now. I forgot to mention that there's 115 here. They're often, when they're in that position, they're often the the 54 meg trap. Well, it isn't in this case, and we now have spot on at 4 watts. That's the maximum the set is wanting to do. So there we are. We've got 4 watts, and that's 4 watts on this test set, which is quite selective. So if you put that on a general meter, it probably read a little bit more. So you're supposed to turn this counterclockwise to achieve 3.8 watts. Well, of course, we don't need to worry about it being 3.8 watts. We want it to be 4. So that is the transmit side done. So let's look at the RF meter. RV103. RV103 is the one at the back. So we want the meter to read 4 watts. Tell you what, that's not wanting to make any difference. 103 is that one. We'll come back to that. We'll do the deviation. So we're looking at 2.2 to 2.5 as a maximum. very low. Wallow. Wallow. Testing 1 2 1 2 1 2 1 2. Just go down a scale and see whether we can see it at all. It should be there. It should be 1 2 1 2. Wallow. Wallow. Let's listen on our monitor receiver. Testing 1 2. Testing 1 2. Very low audio. Might have a break in the mic lead. Might have a duff element. Unless, of course, the deviation control is miles out. So let's have a look at that. Modulation 105. So 105. Should be that one there. 1 2 testing 1 2 1 2. How bizarre is that? Try it there. That's a bit too high. So that had been turned down to nothing. Wallow. Testing 1 2. Wallow. That's it. We're there. And on the monitor receiver. Testing 1 2 3 4 5 5 4 3 2 1. It's amazing what happens to these radios. So we still need to come back to the RF meter. Meanwhile, let's go over to the receiver. These don't have high-low power, which is a bit naughty of them. That sounds absolutely awful. That's actually full volume. Now these sets are susceptible to the detector going out, and looking at where it is, I think it's susceptible to screwdrivers as well. So I want to put this camera on the oscilloscope so we can see the recovered audio, which we need to maximise. I think they've had somebody tighten every screw in this. So the detector coil is there. I still expect more. Yeah, I might want some looking at as well. Okay, let's do a tune-up on the receiver. So they want 5, 6 and 7. 5, 6 and 7. We'll move the camera onto the cyanide meter. We're at 0.3 of a microvolt. Well, that made an improvement. We'll turn that down a bit. 5. 6 was set right. Five, 6 and 7 there. Then 8 and 9, which is part of the IF. So we've got more volume than we did have. Now, I'll see whether we can do this. What I'm looking at now is I'm looking at quality and cyanide. So I'm going to zoom out on both the oscilloscope and the cyanide meter. And what I'm about to, I'm going to switch that so it's on your full screen. And what I'm going to be doing is I'm going to be adjusting the coil there, which is the IF. Yes. Let's check I'm right. 5, 6, 7. 8. Where's 9? I think that's a matter of where fitted, because it certainly isn't on this one. Yeah, so what we're going to do is adjust that for a kind of compromise between quality and maximum cyanide, and I'm going to turn my signal up so we're about, I don't know, I've built a bit more on than that, about 12. So we'll just swap that over. So you can see that's worse. I'm going to put a bit more signal on. Clearly finding a peak there, and I think we have that peak. Just go through that once again. We're now looking back at the cyanide meter, just that we've absolutely made the best job possible. Put a bigger signal back on again. We'll just do this once again. Yeah, it seems a bit quieter than some sets, and I'm just going to take the signal off. That's maximum volume, which I would expect more than that normally. So might be looking at some of the capacitors in the amplifier down there. What we will do is we'll see if we can set up S9 on the meter. So, what we've got, well, virtually spot on S9 to be honest. Does it have S meter? It doesn't say. Sometimes there's a preset tacked onto the bottom. I'm just going to go back to transmit and we'll just see whether we can set that meter up. We can now. So that's set now, so that's good. Good. So the meter doesn't set on this particular version, and as you know, we don't do modifications. If it doesn't have it, we don't do it. So this is the one without, but it's more or less right. So S9 at the moment is being slightly generous at 980 microvolts. You know, so it's not far off the 100, so that's fine. And it's only a guide anyway, isn't it? I mean, some sets are, you never get it anywhere near. Let's just look at, I can't remember what the RF gain, how the RF gain works on these. So you have to switch it in with the local switch. That's it. And DX is always the full amount. So we'll take a synod reading now. And then we can compare the result with what we had off that Comtron the other day, which is the same chassis. So we'll put down 20 dB, 12 dB, which is industry standard, and 10 dB, which is the cheating standard. So let's move that solely onto the synod meter. So for 20 dB, and not all sets can achieve that, it's actually 0.9 of a microvolt, which is very good. For 12 dB, wow, 0.39 microvolts. And for 10, probably change scales, not quite change scales, about there, 0.36 microvolts. So in comparison to the Comtron we did the other day, we got 1.1 for the 20. We've got 0.9 on this, so that's better. We got 0.39 for 12. We've got 0.39 for this set. And on 10 dB we've got 0.3 on that set, and we've got 0.36 on this one. So the quality's better, but it just isn't quite as sensitive. just how it goes, one set to another. But they both exceed the specification by quite a long way. So we just need to do the squelch. I'm going to switch the signal generator off. In fact, I tell you what, we'll go for the S. I'll put the squelch to full on the radio. Okay, so we'll have that opening at S9, and that's what it's doing. And now turn it down to minimum, signal generator off, set the squelch threshold, signal generator on. It's coming on in at 0.3 and dropping off at 0.24. So it's got good sensitivity and it's got a good maximum as well. So what we're now going to do is look into why the volume is a little bit lower than we would expect. I'm going to have a look at those capacitors. So having done all that, I've still got low volume. So I'm going to have to point my finger at the audio IC. But unfortunately, they're not replaceable unless somebody out there knows where you get these 37-year-old Kia devices. So the you can't fit a TA7205 in place because there isn't the room without starting to cut away part of the printed circuit board, which we can't really do with a customer set. So we're going to have to try and recover one from a scrap chassis. I'm going to test these capacitors we've taken out. 240 should be 220, so it's not far out. But I've always said if they're slightly high, they start going high, it is indicative of them failing. So the next one we test is what? 47. That's 58. That is going high. I said before, I don't think I've ever had to change a capacitor in this chassis, but they're so reliable. I don't know what we've got scrap wise. 33, 37. Yeah, so they're all starting to get there, but none of those were faulty. So switch that off. I think the best test for this is actually going into public address. I've tightened up that switch as well. Testing 1 2 1 2 1 2. It's very, very crummy, I think the word is. There's nothing for it. We're going to have to change the audio IC, and I don't know. It's I don't think I've come across this one before. So winding forwards to the next day, and it's actually led us on a merry song and dance as this radio, but it's finished and we've got the volume we want. I went on to the other test set, and it's supposed to be 2 watts output, and it was only 1 watt. And it just was not loud enough. And the PA was not loud enough. So if it wasn't, you couldn't. It's not like you could say there was a fault on the detector not producing enough noise. It was not working on PA either. And we actually dug out another of our sets, Midland 3001, which is the whole business model, why we have one of each set to measure the voltages. And what I did is I've cut and pasted this part of the audio amplifier. We've got the KIA7205, and you can't put a TA7205 in without hacking about the printed circuit board. That might be alright for us, but it's not alright for a customer set. Now these chips are £33 something plus VAT these days, and so I had Mr. Chippy take out the audio IC. Now we have a number of sets which we've put sockets in for ICs, for testing ICs, and I had Mr. Chippy unsolder the audio IC from this set and put it in our test jig, because I wasn't going to change the audio IC when they're £33 a time. So turns out it was alright. So we changed all the electrolytics you'd expect. So we changed 146, 147, 151, somewhere around there. I even changed the big electrolytic, which is nothing to do with the audio amplifier, just for the laugh. And eventually, I even taking out the small decoupling capacitors and making sure that that wasn't where the loss was. Finally found it. 4.7 microfarads. If we put the ESR meter on that one, but taking them apart to this level, you can easily waste a couple of hours, and we only have 2 or 3 40-minute CB sessions available a day. So today's intended CB, there we go, open circuit capacitor. That's showing up. 4.7 microfarad, 6p, 6 pence. And most of those we took out were fine. Some of them were heading in that direction of failing. I'm going to be charging the customer a token £1 for 2 hours work. Plus his service fee. So there we are, that got to the bottom of it. but a lot of work. So it's sat on the aerial now. It's on 19. It's chuntering to itself. I've not screwed up that side panel properly. I can see a screw grinning at me. One niner Roger. And silence. Quite a yellowed front and a faded meter. I think it's been in the lights for a couple of decades, but in lovely condition. I'll just turn the squelch down. No. Anyway, we're doing on the air test with that because we haven't done one for a bit. Oh, I know what I was going to say. So where was that capacitor? Because I was expecting that one to fail. Some of the bigger ones, you know. Actually, this one here, between pin 4 and 7, you've got a 330 ohm resistor. We check that capacitor. We check every one of these little capacitors just in case. Check these on here, but no, it was that one there, 4.7 microfarads. So a nice sensitive set, and it lives to tell another story. So today is Wednesday, and the time has been devoted to this. I did do another session. You know that PMR 446 set we were doing, the Midland base station mobile thing with its umbilical cord legal area which you can't take off. What I've done is to put that on a pole, and I put it absolutely as high as possible. I've actually cut the pole to exactly the length of the cable available, so it is as high as possible, and I've probably gained 18 inches over, was it Saturday's test, which was abysmal when we got a choppy 1.5 miles. So we're going to repeat that test. We hopefully might repeat it today. I might be able to get Mr. C to do this and that, and we'll see whether without CTCSS another 18 inches we get another few hundred yards. So thank you for watching the Midland 3001 1981 repair.